Okay, good morning.
Good morning, sir.
Now last time, and you know very well what happened last time. Last time, we went on to talk about the changes in states of matter, isn't it? So when it comes to, when we talk about changes from solid to liquid, what do we call that change?
Solid to liquid.
Solid to liquid. Melting. Okay? Now, the change from gas to solid, what do we call it?
Sublimation.
Sublimation means. And then solid to gas? Solid to gas. Sublimation is. So, just like they told you, or your summary tells you that sublimation is a change from solid to gas, or from
Yes to
solid without undergoing the liquid state. Isn't it? Okay, so we also went on to talk about, now when we talk about evaporation, from which state to which state? Yeah? Evaporation. Liquid to gas, evaporating. Okay? And then when we talk about condensation, gas to liquid, so it's a vice versa of evaporation. Okay, so today we are going to start with our new topic. I gave you the summary already. So for those ones that were confused with the timetable, you can sit next to somebody. Okay? So that you can all just concentrate there. Okay? Now, today we are going to start with the behavior of matter. Are we together? You already have the summary and you already have the homework to go and read about it, isn't it? So, with behavior of matter, in behavior of matter, we are going to start with our topic of today will be expansion. We'll dwell more into expansion. Now, with expansion is to increase in size as a result of heating. So whenever we talk about expansion, we should know that the size will increase and there is heat involved. Are we together up to there? There is heat involved, and then when a particular substance, metal, let's talk about metal. When the metal is heat, it will become big. Are you getting me? Whenever a metal is heat, it becomes big. So when it's becoming big, the size is becoming big, then that is what we call now expansion. Are we together? Now, we are going to learn about expansion in the three states of matter. And we are going to start with solid. Okay? But before we go there, you have to know exactly how expansion works. Now, matter, already spoke about matter, and matter is what? Occupy space, ne? So, matter expands when heated particles get energy from heat and they move a bit away from each other. Are we together? So when they move away from each other, then it means that's where it doesn't matter if it is gas, liquid, or solid. The particles will always move away from each other. If they were together like this, then they will move away from each other. So for solid, we see it by the increasing of size. But for gas, we have to use, we cannot see it with our naked eyes. Unless we use a dye. Let me say maybe a green dye. And then I just put it in a container. Then I heat it, then you will start seeing better. it will start going further out and then fill up the whole not atmosphere. Now that's not that big. Atmosphere is when we are outside. Okay? Now the space between the particles always becomes big. Yeah, expansion. This one, then if there was little space there, let me say there was little space like this. Now those particles there that are there, later on after you have heated them, let us take, and which tool do we use for heating? The apparatus is Bunsen burner. Now if we heat it there, and then we will see that those particles will move to be, there will be a greater space. Are you getting me? Okay? Now, expansion in solid. There is limited expansion in solid because the particles are perfectly tied together. Okay? Okay, so they are, yeah, so if you look at it, they, on a solid, you cannot take piece of piece with your hands like this, isn't it? But the particles are there, you cannot decide, okay, I want this particle, I want this particle. Are you getting me? So they are packed like this together. So when you heat it, it's only the space in between the particles that they move a bit away from each other. Now when they are moving away, a little bit away from each other, what is happening there? It almost, the size will increase, isn't it? That's why now, the example that is there is the one now of the metal ball. But this one, in your textbook, you can go now to page 44 and look at it. Or for those ones that drew it, you can just check it. Now, this, don't worry about just see this thing. We are going to, I'm going to show you in the laboratory. I'm still going to, we'll go one day to the laboratory and I'll show you. Because some of you now you'll be confused, like, how is it possible that something was not fitting and then later on it's fitting? Now this is just to show you. If you see firstly, that particular ball was fitting into the, into that particular page 44. Page 44. Okay? That ball was first fitting inside that ring, isn't it?
Yes, sir.
But later on when we hit it, when we hit the ball and try to fit it back into the ring, it doesn't fit.
It got bigger.
It got big almost.
Yes,
it
sir.
expanded. That's why it's not fitting there. Are you getting me?
Yes, sir.
Yes, it doesn't make sense to you now. It doesn't make sense to, but you'll see when you go to the laboratory. But then you must just understand now, because we need to understand the concept of expanding most. So it's just to show you that it was fitting, but then when it's hit, it doesn't fit anymore because the size increased. But you are going to see there by the laboratory, because I just want us, when we are going to the laboratory, I want us to do as many experiments as possible together. What does it say?
When the ball is out, it fits. They approve that it
But when the ball is heated, what are they saying then?
it expands, it cannot fit, then it
Yeah, because the particles have now, the space between the particles have increased. But then it doesn't mean that it will be like that forever. And that is the part where we go when we are going to talk about what is it? When we are going to talk about contraction. But that is a story for another day. This thing you also see it in your houses. The door, that wooden door.
Yes.
When it's wet, what does it do? It expands more.
When it rains.
Yeah, when it rains. But then that is a wood now. But for a metal, it also happens to the metal. When you see like this metal here, when it's cold today, it can just move nicely. Move the, but then when it's very hot, it will be very hard for you to close it because it is expanded. Yeah. Just see the home for those. How about most of you people? Your houses are built with wooden doors. So the only way I can say, let's say, the rainwater. That one is now the heat, for example. So it expands. Okay. Yeah, but for metal, the metal will expand during the day, and then it will be very. Even if you check, if this door was really nice, you could see that in the morning there is space here, but then during the day the space will go away. Yeah, you notice it most.
Can you see if it expands?
No, the thing, you see me, like I'm saying, there are some doors here. During the day, those metal doors, when you close it in the morning, you can see that there is a little bit of space there. You can see through, or a little bit of light is coming through. But during the day, you can see that that space has become smaller. It's just not there anymore. Then you will be there confused, like, did somebody steal my door and put for me a new one? And then tomorrow again is the same thing. Are you getting me?
Yes.
So it's because it expanded, then later on it contracted. Okay? So now that is expansion in solids. Okay? Now solids cannot expand at the same rate. Example, the bimetallic strip made of two metals that are joined together, which is iron and brass. Now we wanted to understand now, okay, if we are using different solids, but at your stage, there are a lot of things involved there. Why this one expands more, and why this one expands more than the other one, and this one contracts more than the other one. There are a lot of things involved there, but it's not yet at your stage. So I don't want to confuse you. And you look at me like she's looking at me now. Okay, so when you hit a bimetallic strip, if you look there, it's just a metal, two metals that are joined together. But these two metals, let us say, so this one down here is what? This is just a handle. Okay, it doesn't matter how it looks like. So this one is brass nail. And this one is iron. Okay. Now, when you start, when you hit, when you apply heat there, let me say, for example, you are hitting the brass there. What will happen is that it will bend like this. So I'm not going to write again brass and iron there. You can already see here that this one will be brass and that one will be iron. Now, the thing is, when you hit a bimetallic strip, that's now what we call bimetallic, two metals. Bi means two. Are you getting me? Yes. Two metals, iron and brass. Bimetallic. Okay? When you hit the bimetallic strip, it will bend towards iron because brass expands more than iron. Are you getting me? Yes. So it will bend towards iron then. Okay? Like what you are seeing here.
Yes, sir.
Okay? So you are applying heat to it, but then instead of it bending, let me say, instead of it bending down like this, it bends up like that towards iron. The reason being is that brass expands more than iron. So when brass is becoming, it's expanding, now it's attached to iron, isn't it?
Yes.
So something has to happen. It cannot explode. Because iron expands less more. So what happens is it will just bend that iron because there is heat involved. Iron doesn't want to expand first. So when brass is expanding, it will just bend like this because there is already, this one is not expanding, this is expanding, but then when it's expanding, it's bending the other one. That's why it bends toward that side. Are you getting me?
Yes, sir.
Okay. Now, this mechanism, we use it in, is used in thermostats to control the temperature of an electric iron. That's why you always see that when you are ironing, it always, there's that light that makes the face. You see, that iron, that light, that one, there is a thermostat in there that makes that, okay? So when it expands, then the light it's on. And then as you are ironing, it will cool down positionally. Then the light will go. So again, when the iron gets hot, so it's the same thing what is happening there. So it expands again. That's why you see the light. There is a switch inside there. That is there. And it also happens in ovens. Okay. So a thermostat, to see a thermostat, it's a thermostat is just made up of metals. Okay. So when they heat, when they are heated up, it opens. Thermostat is like, they usually use it in cars. Yeah. So that even the car itself, the water from the radiator, there from the coolant, it cannot just keep on going around, hot water going around. So it stops. The thermostat closes itself when the water is too cold, and then when it's too hot from the radiator, it opens itself to allow the water to go inside the water jackets of the engine there, so that it goes back to the radiator to be cooled off. And it's just a process. Okay? Now, it's used in a lot of things, in heaters, air conditioner, and even fire alarms. Okay? So when the heat is there, you see that alarm is just like that. When the heat is too much, then it will switch itself on. What happens is that that particular metal in the fire alarm, it expanded. So you will say alarm. Alarm. Oh, alarm. Okay, so that was expansion in solid. Now expansion in liquid. A liquid expands, but at a different rate. Now, if we talk about ethanol, ethanol expands more than all liquid. That is why it is used in thermometers. Now, ethanol is alcohol. It's alcohol. Not the alcohol that you drink. It's another type of. There are lots of types of alcohols. So even in the beer that one of your good angle, yeah, that one, there is a bit of ethanol in there. Okay, so that liquid, if you, let me say for example, that's why it's just that for you never saw people doing on DK. So there when they are burning that from bikini, you can see that there is something that goes out first. That is the alcohol, which is ethanol now, that one. So, and then what is left is water. So it expands more. It expands faster than water, and it boils faster than water. That's why it goes fast. So it evaporates fast, but the water is still not boiling. Okay, so it goes fast because it gets hotter quickly most. So it will evaporate quicker, and then what will be left there is water. Okay, that's why we use it in thermometers, because your temperature, we need to know the temperature. So we cannot use something with that allows a very large temperature, very high temperature.
In the wet and dry bulb.
Okay, so that is now about the expansion in liquids. Now expansion in gas. Gases, this is now what you all know. Most of you know this one. So gases expand more than solid and liquid. Expansion and contraction of air is a result of heating and cooling. And that is what happens when it comes to air balloons. Hot air balloons. So, but I know that most of you didn't see that thing. In real life, who saw it in real life?
Which one?
So a lion knows it. It's a big thing, man. So that was the price. The nice colors out there. So then listen, there inside there is a fire here where the person that fire burns. When that air expands, it goes most up there, then it makes a balloon. Not the one your air that you blow inside. No, that one we are using it now. Okay, now for your homework, what I want you to go and do is for you to go and try and see maybe what can I now tell you? No, for water, I don't know whether you oil at home.
Yes.
Paraffin, even if it's paraffin, you don't have that one. Yeah, okay, check up. For just go and try when your mother is cooking. You see, in the what is this? In the pot, you put in water and then oil, just a little bit, and then you see which one will evaporate first. The one that evaporates first, that one is the one which expands. When it's boiling, you can. Oh, and it even makes sense when you are cooking.
When we are cooking rice, that when it's
Not rice, macaroni.
That doesn't go. But you always add water. Why do you add water? But the oil is always there. Then the oil will stay. So for those that don't know it, you must go and try and see and check that. So I want you to go to tell me tomorrow what it means. Okay? So with that said, this will be the end of our lesson for expansion. Okay? So we shall see each other tomorrow. Amen. The test for the test today. If you write today, you will not pass. So we are writing tomorrow. I'll give you a chance to also start because you are coming out of the weekend and even today you don't have my book. So I'll give you a chance tomorrow also, and then you'll write on Thursday.